Okay, so now in the today's lecture, we will start the SFD and BMD for the overhanging beam. So there is a same concept we have to use in the overhanging beam also to draw the SFD and BMD. So nothing is different, but there is a common difference between simply supported and the overhanging beam. What is that particular difference? In the simply supported, the beam is supported at the ends. The beam is supported at the end points. म्हणजे सिम्पली सपोर्टेड मध्ये जिथं बीम तुमचा संपतो त्या ठिकाणी जर सपोर्ट दिलेले असतील तर त्या बीमला आपण काय म्हणतोय simply supported beam म्हणतोय. And there is only two supports in the simply supported. Also in the overhanging also there are only two supports, but there is a one common difference. That is, in overhanging beam the end portion of the beam is extended beyond the support. It may be at one side and it may be at another side. म्हणजे सपोर्टच्या बाहेरला किंवा सपोर्ट पेक्षा जास्त जर तुमचा बीम एका बाजूला एक्सटेंड झाला असेल किंवा दोन्ही बाजूला जर एक्सटेंड झालेला असेल तर दॅट पर्टिक्युलर बीम इज कॉल्ड ॲज ए ओव्हरहँगिंग बीम. सो इफ यू सी फॉर एक्झाम्पल this is the simply supported, this is the simply supported, this is point A and this is point B. So why it is called as simply supported? Because it is supported at the ends. So this is end point A, this is the end point B. Therefore it is called as simply supported, which includes the two supports. But what is meant by the overhanging? So this is the overhanging. So this is point A and this is point B. So this is point A, this is point B. One more figure for the overhanging. This is point A, this is point B. So what is the difference between figure number 2 and figure number 3? So in the figure number 2, the beam is extended at one side only, that is right side. At A point, beam is supported, जिथे beam तुमचा end झाला त्या ठिकाणीच beam ला support दिलेला आहे. But B point, at the B point, there is a extension of the beam. म्हणजे ह्या B नंतर पण तुमचा beam काय झाला एवढा extend झाला. It is extended at the right side. Therefore, it will becomes under the category of overhanging beam. Then what is the in third figure? So in the third figure, what it indicates? The beam is extended at the left side, beam is extended at the right side also. That means both end portions are extended. Therefore, this will be called as a overhanging beam. So this is the basic difference between the simply supported and the overhanging. But if you compare all the three figures, in simply supported also two supports are there. In this particular overhanging also two supports are there. In the third figure also there is a two supports. But where the supports are provided, according to that, there is a difference between the simply supported and the overhanging beam. And that definition we have discussed while starting this particular chapter. So how to identify the simply supported beam? So for that purpose, we have to check their end portions. जर end portion extend झालेले नसतील तर तो beam तुमचा simply supported होतो. If there is a extension of the end portions, it may be at one side. मग एका बाजूला extend झालेला असू द्या किंवा दुसऱ्या बाजूला पण दोन्ही बाजूला extend झालेला असू द्या. That beam will be called as a overhanging beam. Okay, and now we have to solve the numericals based on the SFD and BMD. So whatever the sign conventions we have used for the simply supported beam, same sign conventions without any change we have to use for the overhanging beam. So what is the first requirement? Overhanging beam, the SF and BM calculation will be start from the left side of the beam. This is the step number 1. In simply supported also, we have started the SF calculation and BM calculation from the left side of the beam. Okay, then next, the beam is subjected to the forces, the beam is subjected to the reactions. So the forces which are moving upward, that we have to take positive, and the forces which are moving downward, that we have to take negative. Same sign conventions we have used for the simply supported also. That means if the reactions are moving in the upward direction, that effect of reaction we have to consider positive. But whatever the another loads are there, it may be point load, then UDL we are converted into point load, UVL we are converted into point load. They are acting in the downward direction. Therefore, their effect we are considering it as a negative. And the next, clockwise movement or clockwise couple. Clockwise movement and clockwise couple, that we have to take positive, and anti-clockwise movement and anti-clockwise couple, that we have to take negative. So same sign conventions we have considered for the simply supported beam. If we have to resolve the forces towards the respective points, maybe during maximum BM calculation at each and every point, and in the reaction calculation also we are making summation of BM is equal to 0. So while calculating such calculations, so we are resolving the forces. At that time, these movements are required. So if your movement is clockwise, that effect we have to take positive. If your movement is anti-clockwise, that effect we have to take negative. And same will be applicable for the couple. Sometimes the beam is subjected to the couple, and in the last lecture, in the previous lecture, we have solved the problems based on the couple also. जर couple जर तुमचा clockwise direction मध्ये rotate होत असेल तर त्याचा पण इफेक्ट आपण काय केलाय, पॉझिटिव्ह कन्सिडर केलाय. आणि if that couple is in anti-clockwise direction, then their effect we have to consider it as a negative. But while considering the effect of couple, need not require to multiply by the distance, because already couple is given in kilonewton meter. त्यामुळे त्याला डिस्टन्सला मल्टिप्लाय करायचं नाही, फक्त त्याचा इफेक्ट क्लॉकवाइज आणि अँटी क्लॉकवाइज, अँड दॅट मॅग्निट्यूड ओनली वी हॅव टू राइट इन द calculation. And the effect of couple we are not considering in the SF calculation, because in SF we are taking only forces and force value is only in kilonewton. Keep in mind, आपल्या कपलचं कशामध्ये असतो, किलो न्यूटन मीटर मध्ये असतो, त्यामुळे त्याचा इफेक्ट आपण SF मध्ये कन्सिडर करत नाही. बट देअर इफेक्ट वी आर कन्सिडरिंग इन द BM कॅल्क्युलेशन, दॅट इज विदाउट कपल अँड विथ कपल. So whatever the concepts we have discussed for the simply supported beam, same concepts we are applying for the overhanging beam. फक्त difference काय आहे? There is a difference between simply supported and the overhanging. This is only common difference, otherwise process is totally 100% same. So you can take these particular points in your notebook. Sfd and Bmd for the overhanging beam. Sfd and Bmd for the overhanging beam. In that first point, start SF and BM calculation from the left side of the beam. Write down. Start SF and BM calculation from left side of the beam. The next, upward forces positive, downward forces negative. I have written here. Write down like this. Upward forces positive, downward forces negative. Then clockwise movement positive, anti-clockwise movement negative. And it is applicable for the couple also. That is clockwise couple positive, anti-clockwise couple negative. So these are the three steps or three rules should be applicable for the overhanging beam while solving the numericals. Otherwise, there is no any difference between the simply supported and the overhanging. But the beam's difference आहे, otherwise the process is 100% correct. And how to identify whether it is simply supported or whether it is overhanging? For that purpose, we have to see the structure of the beam. Beam तुम्हाला कसा दिलेला आहे? According to that, we have to identify the difference. Okay? We'll solve the numericals. So I will give one numerical to you. Overhanging beam. Accordingly, just draw the figure. Maximum times for the overhanging beam, the figure will be given. 90%, 90 to 95% problems are there where for the overhanging beam, the figure is given. For the simply supported, sometimes figure is given, sometimes statement is given. By using the statement, sometimes we have to generate the figure. But in case of a overhanging beam, directly figure will be given and you have to go for the solution. So you draw the figure, I will draw here. Okay, so this is the one beam which is supported at point A. Then this is C. It is subjected to the UDL. That is, this is point B. The magnitude of UDL is 25 kilonewton per meter. This is point C, and this is point D. That is, D is subjected to 1 point load of 15 kilonewton. So these distances are also given. This is 3 meter, this is 3 meter, and this is 3 meter. So this is the beam in front of you. So why it is called as a overhanging beam? Why it is called as a overhanging beam? Why it is called as overhanging beam?
End portion of beam extend beyond limit.
Yes, end portion of the beam is extended beyond limit. If you see the figure, this is the point A, which is present at the left side, but at left side the beam is not extended. That is at point A, the beam is not extended. But if you see the right side, the support is provided at point C. See here, the support is provided at point C, and from the point C, the beam is extended at the left side. Sorry, right side. From this particular point C, the beam is extended at the right side up to the point D. The beam is extended from point C, that is from the support point. It is extended to the right side up to the point D, and that D point subjected to the point load. पण ह्या D ला support दिलेला नाही. The support is given at point A, and one more support is given at point C, and at the right side of the point C, the beam is extended. Therefore, this particular beam is called as a overhanging beam, because as per our definition, the end portion of the beam is extended beyond the support. म्हणजे सपोर्टच्या बाहेर जर तुमचा बीम एक्सटेंड झालेला असेल, इट मे बी ॲट वन साइड और इट मे बी ॲट बोथ साइड. मग तो एका साइडला जर एक्सटेंड झाला असेल तरी पण तो ओव्हरहँगिंग बीम असेल, आणि दोन्ही साइडला जर एक्सटेंड झालेला असेल तरी पण दॅट बीम इज कॉल्ड ॲज ए ओव्हरहँगिंग बीम. So like that, we have to identify the difference between the simply supported and the overhanging beam. Okay, so now this is the figure in front of you. So we have to follow the same procedure which what we have followed for the simply supported beam. So what we have to do here? So what we have to do first?
Loading diagram.
Convert into point load.
We have to draw the loading diagrams. That is, here UDL is given from portion A to B. That UDL we have to convert into point load. Okay, therefore at point A, this is reaction RA. So this is point A, this is point B, this is point C, and this is point D. So D point is subjected to the point load of 15 kilonewton. Okay, so C, there is a support means reaction RC. So here from A to B, this is the UDL. So we have to convert that UDL into point load, and that point load we have to represent by the dotted line. So W into L. What is the value?
75.
75 kilonewton. Okay, and it will be acts at the center. So 1.5 meter, 1.5 meter, remaining distance BC 3 meter and CD 3 meter. So these are the your loading diagram. If there is no any UDL, need not required to draw the loading diagram once again. Why we are drawing the loading diagram twice? Because UDL we need to convert into point load. कारण येत्या UDL चा effect आहे असं आपण consider करत नाही. So that UDL we have to convert into point load, and that point load we have to represent it by the dotted line. So that will be the additional point P. पण P ला आपण shear force पण काढत नाही आणि bending moment पण काढत नाही. It is just for your understanding purpose. That is, the point P represents UDL converted into point load. Okay, now our first step, see, reaction calculation. Now you are able to calculate the reaction calculation. That is, upward forces positive, downward forces negative. Summation of vertical forces is equal to 0. So how many forces are there on the beam? Vertical plus horizontal. Sorry, upward plus downward. We have to consider the effect of vertical forces only. But total how many forces are applied on the beam?
4.
4. Which are those?
2 reaction, 1 UDL and 1 point load.
Correct. 2 reactions means reaction RA, RC, they are moving in upward direction, and remaining 2 loads. One is point load. एक point load आहे 15 kilonewtonचा point D वर, तो खालच्या बाजूला चाललेला आहे, and that UDL we have converted into point load. Now tell me, summation of vertical forces means RA minus 75 plus RC minus 15 is equal to 0. Then RA plus RC is equal to RA plus RC is
90.
equal to 90 kilonewton. This is the equation number 1. This is the equation number 1. Now here, if you check the equation number 1, there is a 2 unknowns. RA is also unknown, RC is also unknown. So what we have to do? At one support, we have to take moment is equal to 0. And I have told, always try to take the moment at the left side, that is at point A only. कुठला जरी प्रॉब्लेम आला असेल, तुम्ही C ला जरी समेशन ऑफ EMC जरी 0 केलं तर तुमचे आन्सर सेमच येणार आहेत. But try to follow our standard procedure, that is always we have to take the summation of MA is equal to 0. That is summation of MA is equal to 0. Now tell me, there is no any force at the left side of the point A, but at the right side, how many forces are present? At the right side of the point A, 3 forces, which are, one is 75 kilonewton, that is UDL converted into point load, एक रिएक्शन RC आणि दुसरा हा पॉइंट D वरचा अप्लाय झालेला 15 किलोन्यूटनचा लोड. असे 3 फोर्सेस पॉइंट A च्या राइट साइडला प्रेझेंट आहेत. Okay, so what we have to do? Resolve the forces at point A. Tell me, first force, what is the first force near to the point A?
75.
75 म्हणजे UDL आपण पॉइंट लोड मध्ये कन्वर्ट केला. Whether it is rotating anti-clockwise or clockwise?
Clockwise.
Tell me, 75 into distance
1.5.
1.5, correct. Then next force,
RC.
RC, it is rotating,
Anti-clockwise.
therefore RC into distance between C and A,
6.
6. Next force,
15.
15 plus, therefore 15 positive, distance between D and A, 9 is equal to 0. Now tell me the RC value then. Tell me the RC value, reaction value RC. That RC into 6, that you have to take at right side.
41.25.
41.25. Okay, I will write here 41.25. What about others?
41.25.
Everyone has got the 41.25 kilonewton reaction RC.
Yes, sir.
Those who have not got, if you have got, you can send the answers in the chat box. RC is equal to 41.25. So you are having equation 1. Therefore, from equation 1, that is RA plus 41.25 is equal to 90. Therefore, RA is equal to, what is the value of RA then? 90 minus 41.25.
48.75.
48.75.
48.75 kilonewton. If you do the addition, 48.75 plus 41.25, it becomes 90. And this is the addition of forces which are moving in upward direction. आणि खाली येणाऱ्या फोर्सेसची बेरीज किती आहे ते बघा, 75 अधिक 15. Again it is 90 kilonewton.
90.
That means whatever the reactions you have calculated, it is correct. So like that, only few seconds are required to verify your answers. Just you have to make the addition of forces which are moving in the downward direction and which is equal to forces which are moving in the upward direction. So within fraction of second, we can verify the answers, and then you can go for your further solution. So this is the reaction calculation. Okay, now go for our second calculation, that is SF calculation. SF calculation. Upward forces positive, downward forces negative. Now start from the left side. SF at A. SF at A.
0.
Without load, 0 kilonewton. Okay. Then SF at A with load. What is the value of with load? Means
48.
reaction RA
48.75.
48.75. So here write down 48.75 and this reaction is RC is 41.25. So 48.75 kilonewton, it is moving upward, therefore positive. Then SF at B, whether we have to take without load and with load condition for point B.
No,
No.
Why?
because load is not there.
No force is acting.
No any point load, no any point load or no any reaction. आपण विदाउट लोड आणि विथ लोड कंडिशन कुठे घेतोय? ज्या ठिकाणी पॉइंट लोड किंवा तुमची रिएक्शन असेल त्या ठिकाणीच. बट ऍट पॉइंट बी नो एनी रिएक्शन, नो एनी पॉइंट लोड, देयरफॉर डायरेक्टली आय एम कॅल्क्युलेटिंग SF at B. मग B ला काढताना how many forces are present at the left side? Because we are starting the SF calculation from the left side. Two forces, which are
A and
Reaction and
point load.
रिएक्शन आणि UDL चा आपण पॉइंट लोड मध्ये कन्वर्ट केलेला. मग टेल मी द फर्स्ट 48.75 minus
75
75. What is this answer?
minus
Minus
26.25
Minus
26.25.
26.25.
25 kilonewton. Correct. So this subtraction is also very important. Sometimes we are making the mistakes in this also subtraction. त्यामुळे तुमची खालची सगळी उत्तर चुकत जाते. Okay. Then SF at C. What we have to take here? SF at C means SF at C.
Without load.
Without load.
Correct. Without load. कारण रिएक्शन आहे. रिएक्शन म्हणजेच एक प्रकारचा पॉइंट लोड आहे. SF at C without load means पॉइंट C चा लोड न कन्सिडर करता लेफ्ट साइडला असणारे फोर्सेस. किती फोर्सेस आहेत परत अजून एकदा?
2.
2. त्याचं ऑलरेडी आपण वर कॅल्क्युलेशन केलेलं आहे. सो 48.75 minus 75 it becomes minus 26.25 kilonewton. Then SF at C with load means minus 26.75 plus how much?
41.25.
41.25.
What is this answer?
15.
15 kilonewton. Then SF at D, again there is a point load means without load. So now total forces present at the left side
3.
3. बघा एक रिएक्शन RA I will take 48.75 minus 75 plus 41.25. What is this answer?
15.
15.
15 kilonewton. And last SF at D with load. मग विथ लोड म्हणजे त्या पॉइंट लोडचा पण लोड आपल्याला
Zero.
कन्सिडर करावा लागणार आहे. सो हा 15 आलेला आणि ह्या पॉइंट डी वरचा आपल्याला झालेला विथ फोर्स म्हणजे 15 किलोमीटर इट इज मुव्हिंग इन डाउनवर्ड डायरेक्शन. त्यामुळे तो काय येणार -15. सो प्लस 15 minus 15 it becomes
0.
so your end of the calculation and the start of calculation is automatically it comes 0 means your middle calculation is 100% correct. So like that we have to verify your SF calculation. ऑटोमॅटिकली ते काय होणार आहे? स्टार्टिंगचं 0 असणारच आहे आणि एंड पण तुमचा ऑटोमॅटिक सबट्रॅक्शन करून ऍडिशन करून विदाउट लोड विथ लोड कंडिशन कन्सिडर करून ऑटोमॅटिकली इट विल बिकम्स 0. ओके, नाउ वी हॅव टू ड्रॉ द फिगर. सी, so draw the zero line. So original points A, B, C and D. Tell me one by one. SF at point A without load 0.
0.
With load, what is the value of with load?
48.75.
So here 48.75. Okay, then SF at point B.
Minus 26.25.
-26.25.
त्यामुळं ते कुठे येणार आहे? लाईनच्या खालच्या बाजूला येणार आहे. minus 26.25. Okay, then SF at point C.
minus
Without load.
25.
minus
तीच लाईन पुढे कंटिन्यू होणार. Correct?
25.
Minus 26.25. SF at point C with load.
15.
मग कुठं जाणारा पॉईंट पॉझिटिव्ह रिजन का निगेटिव्ह रिजन मध्ये परत
Positive.
तो वर येणार. त्याच लाईनवर फक्त पॉझिटिव्ह रिजन मध्ये. SF at point D.
15.
So this is 15 kilonewton. This is 15 kilonewton. Now tell me how to draw A to B distance.
Inclined line.
Inclined line. There it should not be parabolic curve. हा जर तुम्ही parabolic curve काढला तर त्या ठिकाणी तुम्हाला ट्रायंगल मिळणार नाहीत. When it becomes triangle, if I will join point A to B as a inclined line. So don't draw the parabolic curve here. So simply join it, then B to C distance, perfectly horizontal line. Then from C point it becomes positive. Then C to D, again this is horizontal line, and then you have to join this. So this is your Vaibhav Zadkar, your mic is on. Vaibhav Zadkar. Your mic is on. Make it off. Okay, so here if you see your SFD, in the portion A to B, it is positive. Then it moves to the negative, and again your SFD will be moved to the positive region. But here in between A to B, here SFD will get cross. This is point Q, and this point is called as a point of contrast shear. Here also at point C also बघा इथं point C वर पण तुमची SF is moving from negative to positive. Point Q ला काय झाले? It is moving from positive to negative. Therefore, this is point of contrast here. And at point C also, once again it is moving from negative to positive. So this point C is also becomes point of contrast here. But we have to check whether at point Q bending moment is maximum or at point C bending moment is maximum, because we are having the two definitions. It is the point at which shear force is zero, but we have to check their bending moment also, whether it is coming maximum or not. And that's why we have to calculate the x distances. Okay, so this is SFD. This is your SFD. Now this Q, we have to shift their lines. So this is point Q, which we have to shift in our original loading diagram also. So this is point Q. Now AQ distance is x. AQ distance is x. Then what is about QB?
3 minus 6.
3 minus 6.
3 minus 6. Means for the maximum BM calculation, it is necessary to calculate the x distance. तुम्ही x distance जर calculate केलं नाही तर तुम्ही maximum BM calculate करू शकत नाही. कारण Q च्या लेफ्ट साइडला आपल्याला x एवढंच UDL कन्सिडर करायचंय. Q च्या लेफ्ट साइडला आपल्याला x मीटरचं UDL आपल्याला काय करायचंय? कन्सिडर करायचंय. But initially we don't have that x distance. Therefore, to calculate maximum bending moment, it is compulsory and it is necessary to calculate the x distance. Getting? So first of all, we will calculate the x distances. See, first of all, draw the symmetrical triangle rule. So this is the triangle. This is point Q. Okay, this is x. This is 3 minus x. What is the top point value? 48.75. And then what is the bottom? I think 26 point.
6.25.
25.
Don't take it as negative. This is positive. So this is the triangle number 1. This is the triangle number 2. Okay. Now apply the symmetrical triangle rule. Tell me x upon
48.75.
48.75, which is equal to 3 minus x upon
26.25.
26.25.
26.25. Now go for the cross multiplication. That is 26.25 x is equal to 48.75 in bracket 3 minus x. Next step 26.25 x. Tell me this answer. 48.75 into 3.
146.25.
146.25
25.
minus 48.75x. Okay, that value I will take to the left side. So 26.25x plus 48.75x is equal to 146.25. From here I will take x common. In bracket 26.25 plus 48.75 is equal to 146.25, not 26. Then tell me the x distance.
1.96.
195
X M meter.
195 meter. So that distance you have to represent in your SFD. बघा SFD मध्ये पण ते distance represent करा 195 मीटर. आणि जी काय तुमची ओरिजिनल लोडिंग डायग्राम आहे वरच्या बाजूला ज्या ठिकाणी UDL आपला डिवाइड झालाय देयर ऑल्सो यू रिप्रेझेंट 1.95 मीटर. इट इज व्हेरी इम्पॉर्टंट. कारण तुम्ही जर क्यू चं डिस्टन्स वर एक्स डिस्टन्स जर वर मेजर केलं तर while calculating maximum bending moment you know or you can easily check that is at the left side of the point Q 1.95 meter UDL is also present. त्यामुळे ते क्यू डिस्टन्स किंवा तो क्यू पॉइंट जर तुम्ही ओरिजिनल डायग्राम मध्ये जर रिप्रेझेंट केला नाही तर समटाइम्स वी आर अनेबल टू कन्सिडर दॅट कॅल्क्युलेशन पार्ट. किती मीटरचं UDL आपल्या ठिकाणी कळणार नाही. दॅट्स वाय यू रिप्रेझेंट द क्यू पॉइंट इन द लोडिंग डायग्राम अँड एक्स डिस्टन्स ऑल्सो. जसं 3 मीटर खालच्या बाजूला दिलेलं आहे A to B तसंच ते पॉइंट A to Q also you have to represent in your original loading diagram. Okay, now we have calculated the x value. Now you are able to calculate the remaining calculation, that is third BM calculation. So for that purpose clockwise movement we are taking positive and anti-clockwise movement we are taking negative. Tell me one by one. BM at A is equal to
0.
0.
so this is the end point. End point of the overhanging beam, that is at point A, it is equal to 0. Now BM at B, first of all calculate for the original point BM at B. Tell me how many forces are present to the left side of the point B?
2.
2 forces. बरोबर. एक म्हणजे रिएक्शन आणि दुसरा म्हणजे UDL. किती मीटरचं UDL प्रेझेंट आहे पॉइंट बी च्या लेफ्ट साइडला?
1.5.
3 meter.
पॉइंट बी च्या लेफ्ट साइडला किती मीटरचं UDL आहे?
3 meter.
1.5.
25 kilometer.
How it is 1.5? Total UDL I am asking. You are converting into the point load, no problem. Point load तुम्ही तुम्हाला convert 1.5 meter तुमचा आलेला आहे. But initially to measure the number of forces 3 meter UDL is present. Correct. Now resolve the forces. आता reaction पहिल्यांदा resolve करा. Reaction is rotating clockwise or anti-clockwise towards point B. Yes.
Clockwise.
Clockwise, therefore positive. So 48.75 into distance
3.
minus 75 UDL is converted into the point load. ओके, दॅट इज पॉइंट पी. मग पॉइंट पी मधलं आणि पॉइंट बी मधलं डिस्टन्स किती आहे?
1.5.
1.5.
This is 1.5. Tell me this answer.
33.75.
33
33.75.
kilonewton meter. Then Bm at C. How many forces are present to the left side of the point C? Once again,
2.
two forces. फक्त फरक काय आहे? मल्टिप्लाइंग डिस्टन्सेस आर डिफरंट. बरोबर, पॉइंट बी ला मल्टिप्लाइंग डिस्टन्स वेगळे होते आणि पॉइंट सी ला मल्टिप्लाइंग डिस्टन्स वेगळे येणार. नाउ रिझॉल्व द फोर्स, that is reaction RA towards point C. Again it is rotating clockwise, therefore it becomes 48.75 into distance
6.
6.
minus परत UDL 75 into distance between point P and C. हे 3 मीटर आणि राहिलेलं 1.5 मीटर. How much?
4.5.
4.5.
4.5. Tell me this answer. 48.75 into 6 minus 75 into 4.5.
Minus 45.
Minus
45.
minus 45 kilonewton meter. Now Bm at D
0.
0 because this is the end. तरी तुम्ही कॅल्क्युलेशन करून बघितलं तरी पण ते 0 येते. Bm at point D is equal to 0 because I have told at the end portion of the beam always your bending moment is equal to 0. मग एका साइडला पॉइंट ए ला तो 0 झाला आणि दुसऱ्या साइडला पॉइंट डी ला म्हणजे पॉइंट डी म्हणजे तुमचा त्या बीमचा एंड पॉइंट आहे. सो इफ यू मेक द कॅल्क्युलेशन then also you will get equal to 0. But I have told you not required to go for the calculation. So immediately you can check whether it is end point or not and you can write directly equal to 0. Then Bm at Q. Now tell me, how many forces are present to the left side of the point Q?
2.
2.
Two forces. What is the
Two.
first one?
Reaction.
Reaction A.
Reaction RE. आणि दुसरा कुठला प्रेझेंट आहे सांगा पॉइंट Q च्या लेफ्ट साइडला?
Point load.
UDL.
UDL. ठीक आहे. किती मीटरचं UDL आहे?
75.
How it is 75?
1.95.
B ला असताना पॉइंट बी ला काढताना आपण 3 मीटरचं UDL घेऊन त्याचं 75 किलोन्यूटन मध्ये कन्वर्ट केला. हा पॉइंट लोड जरी तुम्हाला Q च्या लेफ्ट साइडला दिसत असेल पण तो लेफ्ट साइडला नाही. बघा हा Q पॉइंट काय झालेला आहे? ह्या पॉइंट P च्या इकडे राईट साइडला दिसतोय. त्यामुळे ह्याचा अर्थ असा नाही की हे 75 किलोन्यूटन पण तुमच्या Q च्या लेफ्ट साइडलाच प्रेझेंट आहे. समजतं का? बघा जरी इथं डॉटेड लाईन मी पॉइंट P इंडिकेट केलेला आहे ह्याचा अर्थ असा नाही की इट इज नॉट प्रेझेंट ऍट द Q साइड. हा फक्त इथं ड्रॉ करताना तो बरोबर लेफ्ट साइडला आलेला आणि पॉइंट Q ची लाईन तुमची त्याच्या राईट साइड पासून केलेला आहे. त्याचा अर्थ असा नाही की तो Q च्या लेफ्ट साइडला प्रेझेंट आहे. त्यासाठी यू हॅव टू चेक युअर ओरिजिनल लोडिंग डायग्राम. बघा पॉइंट Q च्या लेफ्ट साइडला एक रिएक्शन RE आणि दुसरं 1.95 मीटर एवढंच UDL त्याच्या लेफ्ट साइडला प्रेझेंट आहे. त्यामुळे हा 75 चा इफेक्ट या ठिकाणी कन्सिडर करायचा नाही. ही डॉटेड लाईन फक्त तुमच्या अंडरस्टँडिंग साठी हा पॉइंट P आहे मी या ठिकाणी रिप्रेझेंट केलेला आहे. बट ऍक्च्युअली इट इज नॉट प्रेझेंट हिअर. हे फक्त तुमच्या अंडरस्टँडिंग साठी मी केलेलं आहे. ठीक आहे. नाउ टू फोर्सेस आर प्रेझेंट. टेल मी फर्स्ट वन रिएक्शन RA, that is RA into distance between A and Q.
1.95.
1.95.
It is rotating clockwise, therefore positive. Minus, tell me, आता 1.95 मीटरचं UDL आपल्याला पॉइंट लोड मध्ये कन्वर्ट करायचं आहे. ठीक आहे. मग काय येणार व्हॅल्यू सांगा? W into L. What is the value of W?
25.
25. What is the length?
1.95.
1.95 into at which distance it is acts? किती डिस्टन्स वर ऍक्ट होईल ते L/2 च्या? मग L इथे लेंथ काय आपली सध्या?
1.95 by 2.
1.95.
divided by 2. जसं आपण मोठ्या युडेलचं 3 मीटरच्या युडेलचं काय केलं 25 × 3 किती आलं 75 आणि ते 75 कुठे इंडिकेट केला 1.5 मीटर फ्रॉम दिस साइड 1.5 मीटर फ्रॉम दिस साइड. फक्त इथं फरक काय आपला पॉईंट क्यू मुळे तुमचं युडेल डिवाइड झालं आणि त्या युडेलची लेंथ आली 1.95. मग त्या छोट्या युडेलचं म्हणजे AQ एवढ्या युडेलचं जर आपल्याला पॉईंट लोड मध्ये कन्वर्ट करायचं असेल तर हा W कॉन्स्टंट राहतो सगळ्यासाठी दॅट इज W × 1.95 आणि तो कन्वर्ट केलेला पॉईंट लोड 1.95 च्या बरोबर सेंट्रल ऍक्ट होणार म्हणजे 1.95 into 25 म्हणजे 1.95 divided by 2. So here RA 48.75 into 1.95 minus 25 into 1.95 into 1.95 divided by 2 म्हणजे हा पहिलं म्हणजे झालं तुमचं W into L आणि 1.95 झालं म्हणजे तुमचं L by 2. Tell me this answer.
47.53.
53 kilonewton meter. Now compare this Q value with remaining values. Which will be the maximum?
Q.
Q.
Q. The bending moment at point Q is maximum as compared to the remaining all points. That means our second definition is also satisfied. That is the point of contrast shear. It is the point at which shear force is coming 0 and at the same point the bending moment is also maximum. So here you have to draw the figure. So draw the horizontal line once again. So this is point A, this is point Q, this is point B, this is point C, and this is point D. Tell me, bending moment at point A, 0.
0.
Bending moment at point Q, maximum value,
47.53.
47.53. Bending moment at point B,
33.75.
म्हणजे 47 च्या थोडा खाली येणार 30
3.75.
25.
33.75 kilonewton. Bending moment at point C,
-45.
आता कुठे येणार तो पॉइंट निगेटिव्ह का पॉझिटिव्ह रिजन मध्ये
Negative.
निगेटिव्ह मायनस
45.
45 and bending moment at point D
0.
0.
now draw the points. Now how to draw the AQ distance first? AQ distance
Parabolic.
parabolic curve. How to draw the BQ distance or QB distance?
Parabol.
आणि अजून पॅराबोलिक कर्व कारण A to B इट इज ऑलरेडी देअर A आणि B च्या मध्ये ऑलरेडी तुमचं UD आहे त्यामुळे UQ पण AQ पण पॅराबोलिक कर्व आणि this QB is also parabolic curve. Then B to C distance
Inclined line.
inclined line कारण ह्याच्यामध्ये कुठलाच UDL नाही त्यामुळे that will be the inclined line and C to D again there is
Inclined.
so here if you check your bending moment diagram is also changes its sign from positive to negative. Your bending moment diagram is also changes its sign from positive to negative. कुठल्या पोर्शन मध्ये तो चेंज झालेला आहे बघा कुठल्या पोर्शन मध्ये आहे
B and C.
B आणि C च्या मध्ये पॉइंट मिळालेला इथं त्याला आपण म्हणूया PQR. नाउ टेल मी व्हॉट इज दिस पॉइंट
Point of contraflexion.
correct point of contraflexure. What is the definition of point of contraflexure? What is the definition of point of
Bending moment
contraflexure?
changes its sign from positive
Correct.
to negative.
It is the point at which bending moment diagram or bending moment changes its sign from positive to negative and vice versa. So that point is called as a point of contraflexure. And what is the second definition? It is the point at which bending moment is equal to 0. बघा दोन्ही डेफिनेशन पॉइंट R ला सॅटिस्फाय होते. पहिली डेफिनेशन काय होती इट इज द पॉइंट ऍट व्हिच बेंडिंग मोमेंट चेंजेस इट्स साइन फ्रॉम पॉझिटिव्ह टू निगेटिव्ह म्हणजे ह्या पॉइंट R ला तुमची बेंडिंग मोमेंट डायग्राम पॉझिटिव्ह कडून निगेटिव्ह कडे गेले आहे म्हणजेच ह्या पॉइंटला आपण काय म्हणतोय पॉइंट ऑफ कॉन्ट्राफ्लेक्चर. आणि दुसरी डेफिनेशन काय आहे ह्याच पॉइंट आर ला आपण पॉइंट ऑफ कॉन्ट्राफ्लेक्चर पण म्हणतो. व्हाय? बिकॉज ऍट दिस पर्टिक्युलर पॉइंट आर बेंडिंग मोमेंट इज इक्वल टू 0 because r point is present on this particular zero line and त्याच zero line वर point r ला तुमचे बेंडिंग मोमेंट व्हॅल्यू काय आलेले आहे? 0 आलेले. therefore this point is r is called as a point of contraflexure. So this is your SFD and this is your BMD. So like that you have to represent all the important points on the figure. जिथं जिथं तुम्हाला असे पॉइंट मिळते त्या ठिकाणी तिथं एरो काढायचा आणि त्या एरोला पॉइंट ऑफ कॉन्ट्राशियर, पॉइंट ऑफ कॉन्ट्राफ्लेक्चर, लाईक दॅट यू हॅव टू इंडिकेट. So this is about the SFD and BMD for the overhanging beam. So nothing different process, nothing different steps. फक्त बीमचा टाइप चेंज झालेला आहे, पण त्या टाइपचा त्याच्या कॅल्क्युलेशन वर कुठेही इफेक्ट होत नाही. Now everyone, have you understood how to calculate the maximum BM and how to calculate the X distance? सगळ्यांना समजलंय का?
Yes, sir.
Yes, sir.
Because sometimes we are making the mistakes while calculating the maximum bending moment at point Q. की जसं आता तुम्ही पॉईंट Q च्या लेफ्ट साइडला दोन फोर्सेस आहेत, त्याच्यामध्ये एक रिएक्शन RA आणि दुसरा 75 किलोन्यूटन. तो 75 किलोन्यूटन तिथं दिसतोय म्हणजे याचा अर्थ असा नाही की तो त्याच्या लेफ्ट साइडला प्रेझेंट आहे. तो आपण कन्वर्ट करून तिथं फक्त एक डॉटेड लाईन इंडिकेट केलेला आहे. डोंट कन्सिडर दॅट पॉइंट इज प्रेझेंट ऍट दॅट इन बिटवीन पोर्शन A to B. इट इज जस्ट फॉर युअर अंडरस्टँडिंग पर्पज. त्यामुळे पॉईंट Q च्या लेफ्ट साइडला दोन फोर्सेस आहेत, पण कुठले? एक रिएक्शन RA आणि दुसरं म्हणजे 1.95 मीटरचं UDL. एवढंच फक्त कन्सिडर करायचं. जसं पॉईंट B ला काढताना आपण काय केलं होतं बघा, पॉईंट B ला बेंडिंग मोमेंट काढताना दोन फोर्सेस, कुठले? एक रिएक्शन RA आणि 3 मीटरचं UDL होतं, म्हणून तो 75 आला. पण पॉईंट Q ला काढताना 3 मीटरचं UDL आहे का? नाही. किती मीटरचं आहे? 1.95. मग 1.95 इंटू 25 आणि तो कुठे ऍक्ट होणार? बरोबर 1.95 डिवाइडेड बाय 2, म्हणजे इकडून 1.95 डिवाइडेड बाय 2, इकडून 1.95 डिवाइडेड बाय 2. So like that we have to first of all take pause, measure the number of forces and then go for your calculation. Now everyone have understood the steps, how to calculate the X distances and how to calculate the maximum BM.
Yes, sir.
Okay, what about others? Everyone?
Yes, sir.
Now you are able to do the calculation of your exercise problem, whatever I have given.
Yes.
So you have to solve that particular problem and you have to send the solutions to me. Okay. So with this today we will stop here. Again, some remaining problems are there that we will take in the next lecture.